This video is going to be about turbulence. Let's go through 3 examples about flow. The first kind of flow we're going to go through is called non-viscous laminar flow. This is the flow that you should see when you're dealing with an ideal fluid. If this is my pipe, all of the streamlines in my pipe go in the same direction or are going the same speed. The viscosity in this situation is equal to 0, so there's no viscosity. Also notice that in this situation, there's no interference from the sides of the pipe. So the flow in the center of the pipe is the same speed as the flow at the walls of the pipe. The next example we're going to talk about is viscous laminar flow. So the flow in this situation still goes in the same direction, but the flow near the edges of the pipe is slower than the flow in the center of the pipe, due to interference with the walls of the pipe and the fluid. The last kind of flow we're going to talk about is turbulent flow. So if this is my pipe, the streamlines are no longer straight, and they no longer all go in the same direction. So in turbulent flow, the streamlines are unpredictable and chaotic. Okay? So now we need a mathematical way to describe how turbulent a flow is. And the way we do that is with something called Reynolds number, which we'll use the symbol capital R to represent. And so the Reynolds number is used to see the transition between laminar and turbulent flow. We can calculate the Reynolds number R by taking our speed of our flow times the density of our fluid times the radius of our pipe and dividing it by the viscosity of our fluid. So if our Reynolds number is less than 1,000, after doing this calculation, we consider the flow to be non-turbulent. And the larger the R you calculate, the greater the turbulence in the flow. That's the end.